All right, AP Calculus. We are on Monday, October 14th, 2019. So 3-7, we're on analytic analysis, where we're talking about the relative extremum, minimums, and maximums of f, but without a graph. Objective, who's going to read it?
Find where the function has relative extremum, minimums, and maximums without a graph.
There it is. All right, so we have dealt with, that is the wrong set of notes, Mr. Mel. We've dealt with the f prime test already, and I'm going to show you the rest of the f prime test. So what we're really doing right now, and I should be writing this out, we're going to be doing the f prime test. You know how to do the f prime test because the f prime test has these three from Friday. I'm going to be teaching you the last three. These are all part of the f prime test, the first derivative test. Tomorrow we're going to be doing the second derivative test. So the f prime test, we need f prime. So let's find that. F prime of x is therefore what? This one's going to be hard because there's two houses that you need to know. What's the outer house? The most outer house? Log house, okay. So what is the derivative of log house?
Negative log.
Say it again. 1 over the inner, right?
Yeah.
1 over the inner, and the inner in this case is 3x squared. So that's daughter. And I need to multiply daughter by dinner. So my inner right now is 3x squared. Which house is dinner? Or which house is inner? Powerhouse. So when I do dinner, what is dinner?
6x.
There it is, 6x. So this is equal to 6x over 3x squared. And can someone reduce that for me?
2 over x.
There it is. So there's our derivative, 2 divided by x. So we're going to go through these and just go through them one at a time. This is a review, so let's find our FCVs. Finding FCVs. How do I find CVs? There's two things that you can do to find CVs. What is the definition of CV? Yeah, so there's two parts. F prime is equal to 0 or F prime DNE. Both of them you have to check. F prime equals 0, that means that your top is equal to 0. Top equals 0. If f prime does not exist, that means your bottom is equal to 0. So you're setting the top equal to 0, see where that happens. Set the bottom equals 0, see where that happens. Okay, setting the top equal to 0, what do we get? Yeah, you can't really set 2 equal to 0. That doesn't work. So top equal to 0, not applicable here. But the bottom equals 0, that's pretty straightforward. It's just x equals 0, right?
Yeah.
Which means we have a critical value at 0. All right, so we're going to go ahead and do what we did before. We're going to make our number line. I'm going to make it up here. I can move this guy down a little bit. There's our number line. This is a number line for all the x coordinates, and we're going to first label all of our CVs. We only have one of them, so that's kind of easy. So we have a CV at 0.
Cool.
What do we do next? Yeah, we're going to test some points. So I'm going to just randomly test to the left and to the right of a CV. What's a good point to the left?
1.
To the right would be 1. To the left would be -1. And I could have chosen -2. I could have chosen -10. -1 is a nice number, though. So when I plug in -1, am I plugging that into f or f prime?
F prime.
All right, so I am plugging into f prime because this is the graph of the derivative now. Everything that I'm dealing with, these definitions, all of their definition comes from f prime. That's why I call it the f prime test. So to figure out where it's increasing and decreasing, I have to make sure that it's either positive or negative on the derivative. So I'm plugging into the derivative, plug in -1 to the derivative here, and I get a positive or a negative?
Negative.
I get a negative because 2 divided by -1 is a negative. So I say over here, this is a negative. Everything over here is negative. And when f prime is negative, what am I? There it is, f decreasing. So label it. This is f decreasing. Arrow. When I plug in 1, where am I plugging 1 into?
The bottom, or x.
F or f prime?
F prime.
F prime. When I plug 1 into f prime, I get
Positive.
a positive, which means f is increasing. All right, so let's go and label our intervals down here. Where are CVs?
0.
So x is equal to 0. Claire, where's f increasing? From 0 to infinity. And if you like inequality notation, you can say x is greater than 0. Stego, where's f decreasing? Negative infinity to 0. There it is. And Gio, how do I say that in inequality notation?
X is less than 0.
There it is. X is less than 0. And please note here that these numbers that I'm using, 0, 0, these come from the critical value. I just messed up there. These come from the critical value. They don't come from the test points. The test points could have been anything. Man, what's going on with my program today? All right, now I need to find where f has a relative extrema. What is the definition of an f relative extrema? It's where f prime, because this is the f prime test, f prime sign change. Write it out to the side of it if you forgot. This is f prime sign change. So let's look up here at f prime. I had a negative, and then I went to a positive. Did I have a sign change?
Yes, sir.
That means that this is not only a CV, but also an f relative extremum. There it is. So come down here, we'll label it, that happened at x equals to 0. All right, what is the definition of f minimum? We'll write it down.
Where it changes from
Negative to a positive. Again, these are just things you're going to have to memorize. And Gio, where's an f max? F prime.
That's 0. Oh, wait. Positive to negative.
Positive to a negative. All right, so where is my minimum?
At 0.
At 0. This is an f minimum as well.
And
So we say
the maximum's at 0 too.
x equals to 0. And then Stego, where is our f max? Where does it change from a positive to a negative? Yeah, it doesn't. Like, look, it went from a negative to a positive. It never goes from a positive to a negative unless I have another CV over here. You can't go backwards. So this one is, yeah, you can say does not exist.
Thank you.
Bless you. Salute.
Guess what I got in the pre-calculation for the matching?
Oh, did you get 8 seconds?
7.9.
7.9? Did you beat me?
No, you were like 7.5.
Oh, yeah. I saw you beat me. I'm like, I bet I can get below 7.9. It took me 10 minutes, but I got it.
Because yesterday I was bored in Mammoth, and I'm like, alright, put my phone out, I'm like,
And I beat you on my computer.
yeah, but it was fun. You use your phone in the second
If I did it on my phone, I could definitely get under 7.5. Claire, I sent it to you too if you
I
wanted
know,
to do
I
it.
saw that, and I started doing it, but then I was painting Squidward for arrows,
Yeah,
so I was like, I'll do it.
Okay. So my question for you guys before we go to the backside is, what does this function look like? We have what the f looks like. Can you picture what it looks like? How can I have a minimum but no maximum?
It just goes,
It's a straight line.
It's a U shape.
Yeah, that.
It's a smiley face.
A U shape like that?
Yes.
That is a graph of x squared. This is natural log of x squared.
I don't know.
So first of all, what does a log function look like? Everyone should know this. A general log function. What does a log function look like? Do I have anything over here on the left-hand side? Does it go like this, or what does a log function look like?
No idea.
Oh boy, we need to review our log properties. So you have that table. It's on the website as well. If I come to the website, if I go back to Mr. Sindel's AP Calculus page, on AP Calculus, the log properties, it is a button if you want to go review it. These are all of the things you have to have memorized about logs for AP Calc. The general function for log looks like, go computer, looks like this. This is a log function. If you forget that, but you can remember an exponential function, you can think of it as the inverse, which means reflecting over y equals x, and you can get the log function that way. This is a review of Algebra 2 and Pre-Calculus, but you should have a function that looks like that. This is a function that technically has a minimum wherever the cutoff point is. It's increasing from 0 to infinity. For some reason, oh, it's decreasing because it looks like this. I actually am allowed to have stuff over on the left-hand side because I squared my input. It's 3x squared. So this is generally what the function looks like. So I'm hoping that by the time that you take the actual AP test, if I give you a function like natural log of 3x squared, you should have a rough idea of what that looks like on a graph.
And that looks like.
This is what that function looks like. It used to be just over here on the right-hand side, but because we squared the input, we're allowed to have negatives. Normally, you're not allowed to have negatives, but because I have a squared, you're only having positives, so I can put whatever I want in there, and I can have something over here to the left side as well. Anyway, let's do the same thing on the back. This is the hardest type, well, not the hardest, but this is a very similar type to AP level question that you might have.
This is high D low. Yes.
Okay, so let's take the derivative.
Low D high minus high D low divided by low low.
Because you start low and then you end low.
Low D high
Basically,
minus
it's all low.
Yes.
high D low
Or you could say
all
there's a
over
little bit of a high.
low low. Oh, by the way, I don't know why I'm randomly telling you this now, but on my website also, I have added a section for each unit. So if you just want to do unit 1 in speed sheet,
Yeah, I saw that as well.
speed sheet on unit 1, just do a speed sheet on unit 1. It has nothing else. If you want to do a speed sheet on just unit 2, come over here to unit 2, and it is just a speed sheet only on unit 2. It is embedded in the website if it would load.
Like problems from like every lesson. Where's that?
This is a matching
Oh.
for all the stuff. So if I do start game, product rule. This is from unit 2. And if you want to do everything, if I come back to AP Calculus at the very bottom, this is a speed sheet for everything that we've ever done.
It's so cool.
So you guys have lots of practice. It definitely took me about 5 minutes to make this. So,
Claire's like, whoa, how
So
long?
complicated. You're like,
yeah, it's not that hard.
5 minutes.
So coming back to this one, let's take the derivative. So let's split this up. I'm just going to go in a circle. I'm going to go Geo, then Stego, then Claire, then Arrow. So Geo, what is low?
I don't know.
Oh, God.
There.
There's low.
X plus 1.
There it is. X plus 1. What's the derivative of the top? D high. What's that, Stego? 2x.
Minus 3. X.
Nope, just 3.
Oh.
Yeah, there you go. Minus high, which is what, Claire?
X squared minus 3x.
X squared minus 3x. D low, Arrow.
Wait, what do you got? X? Oh.
D low
1.
times 1. And then Geo, what's low low?
X plus 1 squared.
X plus 1, quantity squared. There it is. Cool, so there is the derivative. We should have labeled that. That's f prime of x is equal to that. All right, so I have to do that same process again. I have to find CVs. So let's find our CVs.
Wait, should you simplify it first?
Do you want to simplify it?
Doesn't that make it so much easier?
It does make it quite a bit easier.
Yeah.
All right, so the numerator, when I FOIL this out, we should be able to FOIL in our heads. Hopefully, if not, you can go ahead and make your general rectangle like this, chunk, chunk, and multiply using the square. But if you don't want to use the area model, the general rectangle, then you can just FOIL it out. If I FOIL it out, you should be able to get 2x squared. You're going to get minus x minus 3.
Wait.
I did minus 3x plus 2x at the same time, so minus 3x plus 2x will give me minus x.
Shouldn't it be?
And then I have to subtract x squared, then I have to add 3x, and that's all over, leave the bottom the same. X plus 1 quantity squared. Let's get rid of you for now. Oops. And simplifying even further, that's going to be x squared plus 2x minus 3. I feel like I lost all of you.
I feel like
We got
this
it.
was on-
I got Claire. Arrows give me a confused look. Stego and Geo look like they're trying to get it.
Can I have mine out? I should stop using it.
This is yours for keepsies.
No, I have one in my desk.
Oh, okay. They're not for keepsies.
Oh,
All right, so this part came from foiling, and then I had to distribute the negative into these two, so that's where these came from.
for this, could you do like terms?
Yes, and then after that, I added like terms to get down here. All right, so I have my derivative. That is f prime of x now. F prime of x is still equal to this guy. Now let's find the CVs. I'll do this in a different color to make it pop. Let's find our critical values. So again, what is the definition of FCV? Stego. It's where F prime.
Where F prime is equal to 0
And where F prime does not exist. And Geo, where F prime is equal to 0, is that the top or bottom that's being set equal to 0?
Both. Top.
There you go. Top is equal to 0. And DNE, that's where the bottom is equal to 0. So that's how we do that. All right, so Claire, set the top equal to 0. Solve.
So I can just start it, and then you get x plus 3, the quantity of x plus 3 times the quantity of x minus 1. So then your zeros are negative 3 and positive 1.
So there are 2 CVs. And then, Arrow, can you do the F prime does not exist to find the rest of the CVs?
It's negative 1.
How'd you get that?
You set the bottom equal to 0.
And then square root both sides, and I get x plus 1 is equal to 0, and then x is equal to negative 1.
This is a super familiar problem.
That's because it's the exact same problem that we did. Well, it might be in the homework, but I mean, you definitely did it last year.
Okay. Yeah, no, I don't remember them all from last year.
Yes, you do.
All right, now we're going to make our mega number line. I'll make sure that everyone can catch up with algebra. Man, that water in the fish tank is so clear. It looks so nice.
It's so like shocking
Wow,
compared
count
to
the
what
fish.
it was for so
Yeah.
long.
We need to plot all of the CVs.
Okay.
So, oh, we didn't do this problem last year. I'm just realizing. I just made up this problem because the problem from last year was horrible bad. It was just, it was bad.
What's the bed?
Because I think these did not exist, and I only had 2. It was like a horrible problem to review. This one is much better. I made it up myself. All right, so what are the CVs? Geo, list them.
Negative 3, 1, and negative 1.
All right, list them in order now.
Negative 1, 1, 3. Oh wait, negative 3, negative 1, 1.
1. All right, and these are all CVs. Label them CV, CV, and CV. Lots and lots of CVs to be dealing with. All right, so
Wait, how do we do the CVs?
how do we know we're CVs? Someone else answer.
From the
Oh.
Okay. Great.
All right. So we can also label this. We have our x is equal to negative 3, negative 1, and 1. Now I have to figure out where f is increasing and decreasing. How am I going to do that? What am I going to do?
Plug in
Plug in what?
a new number.
Good. What new number should I use?
1, negative 2.
Where's negative 2? In between?
In between negative 3 and 1.
Okay, so negative 2. Let's plug that in. What happens?
Into what?
That's X.
Whoops.
Let's plug this in into f or f prime.
F prime.
Let's plug that into f prime.
Oh, that's a long problem.
So I'm going to rewrite f prime because it'll be easier. I'm going to do what Claire said. I'm going to factor the top, so it's x plus 3, x minus 1 all over x plus 1 quantity squared. What I'm doing is I'm checking each of these parentheses, is it positive or negative, and ignoring the rest. Geo.
Never mind.
So the bottom, is the bottom ever going to be negative?
No.
No.
Why?
Because it's squared.
Because it's squared, thank you. So don't worry about the bottom. Literally plug in negative 2 to both of the tops. So when I plug in negative 2, I get negative 2 plus 3, which is
Negative 1.
positive.
Positive and negative, so then it's a negative.
Oh yeah, my bad.
And then when I plug in negative 2 minus 1 is a negative. The bottom is always positive. Ignore it. Positive times a negative is a
Negative.
negative.
F decreasing.
So that means, yep, we'll label it as well. Thank you, Claire. This is f decreasing.
What happens if you plug in negative 1? Ooh.
If I plug in negative 1, I'll get 0 because that's the definition of a CV.
Oh my bad.
Well, actually, I'll get divided by 0, which you can't have.
It'll does not exist.
All right, now we'll do it again.
Negative 4.
Let's plug in negative 4 all the way over here. When I plug in negative 4, this is going to be,
Negative.
this is going to be,
Negative.
negative times negative is a,
Positive.
which means it is
F increasing.
increasing. There it is.
So you want to plug in how many numbers?
You're plugging in the numbers everywhere. I'm plugging in the numbers everywhere, but there's a shortcut.
On all of the CVs, you want to have one
You're plugging in between all the CVs, exactly.
A lot of numbers.
Yeah.
Sometimes you only have to plug in 2 on either side, but in this case you're going to have to plug in a lot.
Oh,
It's in between.
All right, Stego, choose a number that's in between -1 and 1.
0.
Oh, that's a good number. I like that one.
How did you think of that number?
Did you choose a half?
I did 0.5.
Oh, Arrow, no.
How did I miss that?
Stego, it's on you. 0 plus 3 is,
3.
which is
Positive.
positive. And when I plug in 0 here, it's
Negative.
positive times negative is a
Negative.
negative. And that means it is F
Decreasing.
decreasing. I want to point out something. This is the trick I was trying to teach you from Friday, which is if I look at the power, this is a power of 1, this is a power of 1, this is a power of 2. If I have an odd power, it changes when I jump over the CV. If it has an even power, it does not change. When I plugged in -1, where did -1 come from? Did it come from this CV, or this CV? Was it the left, right, or bottom?
Bottom.
The bottom. The bottom had a power of,
2.
which is even. Even means I don't change. Look, it went from negative to negative. It didn't change because the exponent was 2. I'm trying to show you shortcuts. Take a guess now. CV of 1 came from left or right?
It's going to be positive.
The CV of 1 came from the
Right.
right, which had an exponent that was odd.
Oh.
Odd exponent means it changes, which means I will change over here to a positive. I don't even have to plug in. I could check my work, but it is positive, which means this is F increasing.
Yeah. Cool.
If we did a more in-depth pre-calculus or algebra 2 class, you'd know this, knowing that it jumps or it changes sign depending on what power you're at. It's a very in-depth view of rationals and polynomials. I think Mammoth kids learn this and then they spend a day on it and then they forget it. But this is where you really need to know that because it saves you a lot of time.
See, we learn it in a setting where we're actually going to need it, so that means we'll remember it.
Well,
I agree.
It's in a setting where we might need it, so we might remember.
Let's label what we just found. Let's label this stuff. Where's F increasing?
From negative infinity to -3.
And,
And
or I should say or,
Infinity to 2.
or from
1 to
1 to positive.
1 to positive infinity.
I love infinity.
Yeah, I need to get better at drawing them on the stylus.
Mm-hmm.
Where is F decreasing?
From
Be careful about this one.
-3 to -1 or -1 to 1. I made this mistake about 5 times on the homework before I got it.
So why is... Sorry, I made a mistake here.
It hits 0, and there's the point where it's not decreasing. It's exactly equal to 0.
You are labeling exactly what I'm trying to say, but I think Stego and Geo aren't quite there yet.
Oh, yeah, I got it.
I'll repeat it just to make sure that everyone has it for the video as well. At -1, I am not increasing nor decreasing because that is a CV. The definition of increasing and decreasing is I'm either greater than or less than 0. This is 0, which means it's not increasing, it's not decreasing. I cannot include -1. The way that you get rid of -1 is by writing it like this. It's saying I go up to -1 without including -1, and then I start at -1 without including -1 onto positive 1. So far, so good? All right, so now I need to find relative extrema. Again, what is the definition of relative extrema?
Where there's a sign change.
For F or F prime or F double prime? F prime sign change. Write it off to the side again to make sure that you remember it. This is F prime sign change. So, where are there some sign changes?
-2, 0, and 2.
Careful, you're looking at the CVs where there is a sign change. So your possibilities are -3, -1, and 1, but not all of those are sign changes. Which of them are sign changes? At x is equal to -3 and 1. It's not a sign change at -1 because it went from a negative to a negative. And a quick way, because I will be asking this on the self-check, the pretest, and the test, is I'll just ask you, where are the relative extrema based on the equation? And you'll just be like, oh, take the derivative, even. Oh, there's an odd power, there's a relative extrema. Quick way of finding relative extrema. Find the odd powers. All right.
Wait, so as soon as you have an odd power, you can just say that when you set that whatever and is equal to 0, that's the relative extreme.
Yep. It's a quick way of finding relative extrema. It's the odd powers. We'll make that note here. This is odd powers. All right, where are our minimums? Before that, though, what is the definition of F minimum? Stego. F minimum is F prime.
When the sign changes from negative to positive.
There it is. And then Geo, F prime for maximum is?
Positive to negative.
There it is. All right, so where does my function have a minimum?
From -2 to 2.
At which CV, which of these CVs?
1.
Why 1?
Because it changes from negative to a positive.
There it is. X equals 1. Do I have any other minimums?
Yes.
Where?
Oh, actually don't.
Where do I have X or F maximums?
-3.
At -3. Why?
Because it changes from a positive to a negative.
Positive to a negative at that CV. Again, never accidentally use these test points. These test points should never be used in your answers down here. They were just test points. They weren't actual points. You should only be using CVs.
When we take our AP exam, are we allowed to have like multiple colored pens?
I
Or should it
think you only get number 2 pencils.
Oh, perfect. That'll be fun.
That's all I have for the notes.
Can I
It's
put
like
a
the
button?
wooden.
Yeah.
Everything